In this episode, we'll be looking at the basic principle behind the sort of rocket that most people are familiar with. A typical rocket's purpose is to move its payload from Earth to an orbit around Earth. To do this, it requires a lot of energy. This energy is stored chemically as a fuel and an oxidizer in two large tanks. They are stored at extremely low temperatures to make them as dense as possible. When the two are combined and burned in the combustion chamber, energy is released in the form of a gas. A hole in the combustion chamber allows the gas to be expelled and accelerate the rocket. The rocket's goal is to provide the necessary change in velocity the payload requires to get to its orbit. We call this change in velocity delta V. The rocket accelerates due to the conservation of momentum law. When some amount of mass times some velocity is ejected from the rocket gains an equal momentum in the opposite direction. As the rocket burns fuel and oxidizer, it decreases in mass. This means that its acceleration must increase because the thrust is about constant. At liftoff, the rocket accelerates slowly, but as it's about to run out of propellant, the acceleration is at a maximum. At the very end, the acceleration is limited to the mass of the rocket without the fuel and oxidizer, also known as the dry mass. Most of this mass is useless. The huge tanks aren't needed if there's only a few thousand liters of propellant left. And who needs huge, rapidly burning engines when you're about to run out of propellant? That's a lot of unnecessary mass. Because of this, a lot of delta V is missed out on. How can this problem be solved? By using a second stage. Using a second stage means that once the huge tanks are no longer useful, they are jettisoned. Now a smaller rocket is ignited, one with smaller tanks and a lighter, more efficient engine providing less thrust. Now, as the second stage is about to run out of propellant, the dry mass is quite small. The result is that not so much of that velocity is missed out on. By using two stages, the delta V is dramatically increased without adding too much weight. The energy expelled from the rocket comes mostly in the form of kinetic energy. This is the energy the exhaust gas has due to its velocity. Notice how the kinetic energy is proportional to velocity squared, while momentum is proportional to only velocity. If the gas is accelerated to a high velocity, a huge amount of energy is required, and only a reasonable amount of momentum is gained. This is not efficient. The velocity should be minimized so that a large change in momentum is possible with the available energy. However, minimizing the velocity means that more mass is required. A rocket only has so much available mass in the form of propellant. So, even though it seems inefficient, the engine should accelerate the gas to a huge velocity. In the next episode, we'll be looking at the rocket engine's nozzle. We'll look at what it does, how it works, and why it's used. Thanks for watching. Feel free to like and subscribe in case you liked it. Click the bell next to the subscription button if you want to be notified when I upload a video. I also have a Patreon where I share all sorts of things. The link is in the description. I'll see you next time.